Usually when we talk about a medical diagnosis, there's this expectation of clinical precision. Right.
Oh, absolutely. We like things to be highly visible.
Yeah, exactly. I mean, you break your arm, the x-ray shows a jagged white line on the femur, the doctor points right to it, and you know exactly what the structural reality is. You don't really have to guess. The image just tells the whole story.
Right, because we are wired to categorize information as binary, Yeah. It's broken or it's unbroken, it's healthy or it's sick.
But then think about when you look at a neurological scan or you try to diagnose a really complex autoimmune response. Suddenly, that x-ray machine is totally useless.
Oh, completely useless. Yeah.
The diagnostic landscape just becomes incredibly murky. You aren't just looking at a bone anymore. You are looking at these overlapping compounding systems reacting to, unseen chemical triggers.
And the exact same illusion of precision happens in the financial markets, honestly.
Exactly. We look at a stock ticker, we see a green arrow or a red arrow, and we think, oh, I understand what's happening. Green means the company is healthy, red means it's sick. It feels like an x-ray.
Which is, frankly, the fastest way to lose your capital.
Yeah.
The ticker price is just the surface symptom. I mean, if you actually want to understand the underlying mechanics, if you want to be a structurally sound retail investor, you have to look way past the binary color coding.
Right. You have to get into the messy, complex machinery of the corporate organism itself.
Which brings us to today.
Yes, that is the exact mission of our deep dive today for you listening. We are looking past the ticker to analyze a profoundly revealing piece of corporate architecture. Specifically, we're breaking down the Analog Devices Q2 2026 earnings call.
Yeah, and for anyone tracking the ticker symbol ADI, I mean, this call is a masterclass.
It really is. It's a masterclass in reading the structural health of not just one company, but really the entire global push toward automation. So today, we're going to break down the mechanics of their financial results.
We're going to translate the deep-level engineering shifts happening in their target markets, too.
Exactly. And evaluate the incredibly aggressive capital allocation they are deploying right now. But before we get into the headline numbers, we really need to set the stage.
Right. We need to understand the fundamental layer of reality this company operates in. Because Analog Devices is not manufacturing the central processing units you find in a laptop.
Right. When people hear the word semiconductors, they instantly think of digital brains. NVIDIA GPUs, Intel CPUs.
Chips that process logic in ones and zeros, yeah.
Exactly. But the physical world, the actual environment we inhabit, does not natively speak binary code.
No, it speaks in continuous variables. Think about temperature fluctuations in a massive chemical vat.
Or the changing pressure of an airplane wing.
Right. Or just the sound wave of a human voice. Or even the exact resistance a robotic surgical arm feels when it's pressing against human tissue.
Wow, yeah.
That is an analog reality.
So if you want a cutting-edge artificial intelligence model to optimize an automotive manufacturing plant, you have this immediate translation problem.
Right.
Because the AI only understands ones and zeros.
And the factory floor only produces analog physics.
Right. You cannot plug a digital brain directly into an analog world. You have to build a highly engineered bridge.
You need silicon that can sense the analog reality, capture it with extreme fidelity, and then translate it into a digital data stream that the AI can actually crunch.
And then it goes the other way too, right? Once the AI makes a decision, you need another bridge to translate that digital command back into physical analog force, like telling a motor exactly how much torque to apply.
Exactly. And ADI builds those bridges.
They design the analog to digital converters, the digital to analog converters, the power management integrated circuits. I mean, they are the nervous system of modern technology.
They really are. So when we look at the financial readout from their Q2 2026 call, we aren't just looking at how many units ADI moved out of some warehouse. We are looking at a real-time diagnostic scan of global capital expenditures in artificial intelligence, electrical grid modernization, and advanced defense systems.
And let me tell you, that diagnostic scan is flashing incredibly strong signals right now.
Extremely strong.
Let's start with the sheer velocity of the headline numbers. And keep in mind the geopolitical and macroeconomic context here. Because CEO Vincent Roche explicitly noted this at the start of the call. We've got stubborn inflation, fluctuating consumer sentiment, high interest rates.
It is a hostile environment for hardware manufacturing, to put it mildly.
Really hostile. Yet the revenue ADI posted is just staggering. They hit a record $3.62 billion in top-line revenue for the quarter.
Which is massive.
It's a 15% increase sequentially, meaning quarter over quarter,
Yeah.
and a massive 37% increase year over year.
A 15% sequential jump in hardware is honestly an anomaly.
Right, because software companies can scale revenue that fast since the marginal cost of distribution is basically zero. You just issue more licenses.
Yeah, but hardware requires raw silicon. It requires fabrication time, packaging, and real-world logistics.
So a 15% jump in 90 days implies that a massive bottleneck was either unlocked or customer demand is so acute that orders are just accelerating in real time.
And the bottom line metrics follow that exact same aggressive curve. I mean, earnings per share, or EPS, hit a record $3.09.
Wow.
Yeah, that is up 26% sequentially and 67% year over year.
That's incredible. But the metric that truly defines the operational leverage of this company, the number that completely recontextualizes what they do, is their gross margin.
Oh, the gross margin is the real story here.
They posted a 73% gross margin, which is up 180 basis points sequentially and 360 basis points year over year.
I mean, a 73% gross margin in physical semiconductor manufacturing almost defies the laws of industrial physics.
It really does. For the listener, think about it like this. If you sell a highly engineered microchip for $1, you are keeping 73 cents after accounting for the direct costs of manufacturing, materials, and direct labor.
That approaches software as a service economics, but they are dealing in raw materials, clean rooms, and physical logistics.
Right. So how are they achieving that? Because, okay, let's unpack this. If I see 67% year-over-year earnings growth and a 73% gross margin during an inflationary cycle, my immediate assumption is that they are just squeezing their customers.
That's a very fair assumption.
Like, they recognize that supply chains are tight, they hold a monopoly on certain critical components, and they are just aggressively jacking up prices to pad the bottom line. Is that what's happening?
That is the exact crucial assumption we need to test. Because during periods of macroeconomic friction, companies with pricing power often use inflation as air cover.
Right, to permanently elevate their margin profile.
Exactly. And analyst Vivek Arya from Bank of America Securities zeroed in on this exactly during the Q&A. He challenged management to clarify how much of this revenue beat was a permanent structural shift versus tactical, temporary pricing leverage.
So what was the CFO's defense?
Right.
Did he admit to price gouging?
Well, CFO Richard Puccio was actually remarkably transparent about the mechanics here. Vincent Roche also chimed in to clarify the strategy.
Okay.
Yes, they did execute tactical price increases across their portfolio. I mean, their input costs, raw wafers, specialized chemicals, foundry fees, energy, all of that escalated due to broader inflation.
Sure, that makes sense.
So they passed a portion of those costs through to the customer to protect their baseline profitability. However, Puccio explicitly stated that these tactical pricing actions played out exactly according to their internal modeling.
Okay, meaning what exactly?
Meaning they anticipate those price hikes will only contribute a couple of percentage points to their total growth rate for fiscal 2026.
Wait. Just a couple of points. But top-line revenue was up 37% year over year. That leaves a massive gulf. I mean, if pricing only accounts for a fraction of the growth, the rest has to be sheer physical volume and product mix.
And that right there is the underlying strength of the quarter. They're simply selling a vastly higher quantity of chips. And crucially, they are selling a higher proportion of their most complex, highest margin silicon.
So this is not an artificial inflation squeeze at all.
No, not at all. The end user demand for the analog to digital bridge is genuinely surging.
I want to dig into the mechanics of how they actually physically maintain a 73% margin while pushing that kind of volume. Because they don't operate like a pure fabless semiconductor company, right?
Right, they have a very unique setup.
Like, NVIDIA doesn't own factories. They design the chip and pay TSMC in Taiwan to actually print it. And on the other extreme, Intel historically owned all their own factories. ADI kind of operates in a middle ground, don't they?
Yeah, they utilize what is called a hybrid manufacturing model, and it is a critical component of their financial architecture.
How does that work?
Well, analog chips, by their physical nature, do not always require the bleeding edge, 3-nanometer extreme, ultraviolet lithography that a modern AI processor needs.
Okay, so they don't need the absolute newest factory equipment.
Right. A precision temperature sensor or a high-voltage power regulator might function perfectly well on a 90-nanometer or 180-nanometer manufacturing node.
Which is much older, legacy technology.
But highly, highly reliable. ADI actually owns their own fabrication facilities for these mature nodes, and the capital expenditure on those internal fabs was depreciated years ago. The equipment is fully paid off.
Oh, wow. So when they run a batch of power management chips through their internal, fully depreciated fabs, the unit economics are spectacularly profitable.
Exactly. That is the bedrock of the 73% margin. Then, for the highly complex, logic-heavy mixed signal chips that require smaller geometries, they outsource to external foundry partners like TSMC.
That's brilliant. This hybrid approach gives them incredible cost control over the bulk of their volume, while still retaining access to cutting-edge nodes. And they do it without the multi-billion-dollar capex burden of building a 5-nanometer fab from scratch.
It's a very resilient model.
So they have insulated their margin structure at the foundry level. But if the overwhelming upside to the revenue beat is driven by sheer volume, like an avalanche of physical demand, we really have to map out where all these chips are actually going.
We do. And if you break down ADI's revenue by end market, you are essentially looking at a heat map of global industrial modernization. They segment their business into industrial communications, automotive, and consumer.
Well, let's just bypass consumer entirely for now. It only represents 11% of their business, and management noted it's actively declining due to broader retail headwinds.
Yeah, consumer isn't the story here.
The real narrative, the structural engine of this company, sits inside the industrial segment.
Right.
I mean, it accounts for a full 50% of ADI's total revenue.
And in this Q2 period, industrial posted a 56% year-over-year growth rate.
Which is insane. To put that in perspective for you listening, a 56% growth rate in a division generating nearly $2 billion a quarter is colossal.
It's a massive number.
And the term industrial is doing a lot of heavy lifting here. When retail investors hear industrial sector, the mind tends to wander toward heavy machinery, cement manufacturing, maybe legacy assembly lines.
Which is fundamentally misaligned with what ADI is actually supplying. Vincent Roche spent significant time during his opening remarks redefining this segment for the analysts.
Right. What did he say?
He basically said ADI's industrial portfolio is essentially the underlying hardware for the fourth industrial revolution.
Okay, so highly advanced stuff.
Very. It is characterized by extreme technological complexity and product life cycles that can stretch for 2 decades. The most prominent driver within this segment currently is their aerospace and defense business.
Which hit a new all-time revenue record this quarter, right?
Yes, a massive record. Roche specifically cited an increased global focus on national sovereignty concerns as the catalyst.
Yeah, it is very diplomatic phrasing for the reality that the geopolitical climate is highly destabilized right now. Nations are aggressively modernizing their defense capabilities.
And modern defense is no longer defined with the thickness of armor plating. It is defined by the density of semiconductors.
Give me an example of that.
Well, consider a modern phased array radar system. Instead of a single large satellite dish spinning mechanically to track a target, a phased array radar uses thousands of tiny individual antenna modules spread across a flat panel.
Okay.
Each one of those modules needs to instantaneously shift its phase to electronically steer the radar beam in microseconds.
Wow. Which requires an immense number of analog to digital converters to process the returning radio frequencies, and highly resilient power management chips to ensure the radar doesn't drop offline during a power surge.
Furthermore, these defense platforms, whether it's secure satellite communications, electronic warfare suites, or guided munitions, operate in extreme environments.
Oh, absolutely. They face massive temperature fluctuations, extreme vibration, intense electromagnetic interference. The silicon literally cannot fail.
So when a defense contractor designs a system, they don't source the cheapest commercial silicon available. They source ADI's mil-spec, highly engineered components.
And once an ADI chip is written into a Department of Defense contract blueprint, it stays there for the 15 to 20-year lifespan of the platform.
Exactly. It generates a locked-in annuity of high-margin revenue. It's incredibly stable.
Now, beyond defense, Roche highlighted the automation megatrend. He noted a massive push toward the onshoring of advanced manufacturing.
Right. Coming out of the pandemic supply chain crises, corporations realized the inherent risk of having their entire manufacturing base localized half a world away. They want factories closer to the end consumer now.
But because domestic labor in North America or Europe is vastly more expensive and often pretty scarce. These new facilities cannot operate on legacy labor models.
No, they have to be digital factories. And the transition from mechanized automation to true autonomous manufacturing requires a quantum leap in sensing technology.
Because a mechanized robotic arm just blindly repeats a programmed motion, right? It doesn't know if a screw is cross-threaded, it just turns the driver.
Exactly. But an autonomous robot requires real-time edge intelligence. It needs torque sensors to feel the resistance of the screw. It needs optical sensors to verify the alignment.
And localized processing to adjust its motion instantly without waiting for some central server to send a command.
And Roche actually called out humanoids and other advanced robotics modalities as a rapidly increasing opportunity pipeline for them.
Wait, really? Humanoid robots?
Yeah. Every single joint on a highly articulated humanoid robot requires motor control feedback loops. ADI is selling the exact chips that provide that closed-loop control.
That is wild. But another subsegment of industrial that fascinates me is what they call ETM, electronic test and measurement.
Oh, ETM is incredible. It is the invisible backbone of the entire technology sector.
So explain that a bit more.
Well, as innovation cycles compress, meaning companies are trying to release new generations of AI servers or electric vehicles faster and faster, the engineering complexity skyrockets.
Right.
You cannot develop a next-generation 800-volt battery system for an EV without incredibly sophisticated testing equipment to prototype it, stress test it, and debug it.
Exactly. If an engineering team is developing a new gigahertz frequency secure communication protocol, the oscilloscope they use to analyze the waveform has to be fundamentally more advanced than the protocol itself.
The testing equipment literally has to be the most precise technology in the room.
And ADI supplies the cutting-edge radio frequency transceivers, mixed signal converters, and high-precision amplifiers that go into those multi-$100,000 electronic test and measurement machines.
So it's basically a derivative play on global R&D spending. As long as the broader market continues to push the boundaries of physics in AI and electrification, the demand for ADI's high-end ETM components will scale linearly.
That makes total sense. Now, the final major pillar within industrial is the energy sector. Specifically, the modernization of the electrical grid.
We are watching a simultaneous disruption on both ends of the grid architecture right now.
Yeah, on the generation side, we're shifting away from massive, predictable fossil fuel plants toward intermittent, decentralized renewable sources like wind and solar arrays.
And then on the consumption side, we are dropping massive, unpredictable loads onto the grid, like a neighborhood full of electric vehicles plugging in at 6 p.m.
Or a new hyperscale AI data center drawing enough megawatts to power a small city.
Exactly. And the legacy grid was not designed for multi-directional, highly volatile power flow.
No, it wasn't. So to prevent catastrophic blackouts, utility companies have to deploy localized edge intelligence. They need smart meters, grid-scale energy storage systems, and highly responsive power routing hardware.
And Roche highlighted that ADI is taking the battery management system technology they originally developed for electric vehicles and adapting it for grid-scale energy storage systems.
Wow. That's a smart pivot.
Very smart. That specific business segment grew more than 50% in fiscal 2025 and shows zero signs of deceleration.
Okay, so the 56% growth in the industrial segment isn't some cyclical blip. It's anchored across defense modernization, autonomous manufacturing, global R&D instrumentation, and grid restructuring.
Those are multi-decade secular tailwinds.
All right, let's shift our focus to the communications segment. It represents 15% of their total revenue, and it grew 79% year over year.
But the aggregate number really masks the truly explosive narrative beneath it.
Right, because historically, the communications segment consisted of macro base station equipment. Think like 5G cell tower rollouts.
But the composition has radically shifted. The data center business now accounts for more than 75% of their total communications revenue.
Wow.
And that specific data center slice grew by more than 90% year over year.
A 90% expansion inside of 12 months. That is basically the physical footprint of the artificial intelligence boom, quantified in silicon.
It really is. Analyst Joe Moore from Morgan Stanley pressed for the exact mechanics of this growth during the Q&A. He wanted to know if this was just a surge in standard power management chips or something more structural.
And what did they say?
CFO Richard Puccio detailed that the 90% growth was fueled equally by two distinct technological disciplines: their optical portfolio and their power portfolio.
Okay, let's break that down. Why is optical growing so rapidly?
To understand that, you have to look at the architecture of an AI data center. You aren't just sending data from a server to the internet. You are sending massive terabyte-scale data sets between thousands of internal servers simultaneously to train an AI model.
Right, and traditional copper wiring completely fails at those data rates. The electromagnetic interference is too high, and the signal degradation over distance is just too severe.
Copper simply cannot carry the bandwidth required for an AI training cluster. So the industry has shifted to optical interconnects, using lasers to transmit data via fiber optic cables between the server racks.
But the processing chips themselves still operate on electrical signals, right? They don't run on light.
Exactly. So at the end of every single fiber optic cable, you need an optical transceiver to convert the photon light signal back into an electrical electron signal.
And let me guess, ADI manufactures the high-speed analog components inside those transceivers.
You got it. The transimpedance amplifiers, the laser drivers, the clock and data recovery circuits. Every time a new GPU cluster is deployed, the density of optical interconnects scales exponentially, driving massive volume for ADI.
That's incredible. Now, what about the second half of that data center growth? The power portfolio.
Right. As we discussed, an AI data center draws a phenomenal amount of electricity, but it doesn't draw it smoothly. An AI workload is highly volatile.
Like when a massive training computation begins, the power draw spikes instantly.
Instantly. Managing the delivery of that power from the massive grid input down to the delicate low voltage requirements of an individual GPU without generating catastrophic heat or causing a voltage collapse is one of the hardest engineering challenges in the industry right now.
Which provides the perfect transition into the most aggressive strategic move discussed on the call, ADI's planned acquisition of Empire Semiconductor.
Yes, here's where it gets really interesting.
We have already established that ADI is a behemoth in power management. I mean, they bought Linear Technology for $14 billion. They bought Maxim Integrated for $20 billion. They have thousands of the best power engineers on the planet.
Right.
Yet they are spending capital to acquire a relatively unknown, privately held semiconductor company.
Yeah.
Analyst William Stein from Truist Securities raised this exact point. He essentially asked, given your legacy dominance in power, why couldn't you just build this technology internally?
And Vincent Roche's response contained 4 words that define the current state of the AI arms race. Time is of the essence.
Time is of the essence. Wow.
Yeah. The performance demands of AI accelerators are compounding faster than traditional semiconductor development cycles can accommodate. Roche noted that the biggest structural bottleneck holding back the entire AI industry right now is power density.
Okay, let's break down the physics of power density for the listener. Why is this the specific choke point?
Well, every generation of AI processor requires more current at lower voltages to operate at peak logic speeds. Traditionally, to step down the massive voltage coming from the server rack into the precise voltage needed by the chip, you use an array of external components.
Like inductors, capacitors, discrete voltage regulators.
Exactly. You physically solder them onto the motherboard around the processor.
But AI chips are getting so massive, and data centers want to pack so many of them onto a single board to reduce data latency that you physically run out of real estate.
Right. You cannot fit the necessary power components on the board without pushing the processors further apart.
Which is a huge problem, because pushing them further apart increases latency and degrades performance.
Yeah.
It defeats the purpose. So what does Empire Semiconductor do differently?
Empower developed a proprietary technology that circumvents this architectural limit entirely. They engineered an integrated voltage regulator, or IVR.
IVR, okay.
Instead of spreading discrete components across the motherboard, Empower's technology integrates the power regulation directly into a single, specialized silicon die. They utilize highly advanced silicon trench capacitors that hold massive amounts of energy in microscopic physical structure.
Oh, wow. So it allows for true vertical power delivery. You can place the voltage regulator directly underneath or adjacent to the processor package itself.
Exactly. Roche stated this architecture shrinks the customer's power footprint by up to 4 times. You eliminate the sprawling city of external components and replace it with a single, highly dense skyscraper of power delivery.
But the space saving is only a secondary benefit, isn't it? The primary advantage, and the reason ADI bought them, is efficiency and speed.
You're exactly right. Because when power has to travel across an inch of copper tracing on a motherboard, you suffer resistive losses. It generates heat, and you lose electricity.
So by delivering the power vertically, right at the point of load, how much are they saving?
Roche estimates they can slash data center compute power consumption by 10 to 15%.
10 to 15%. When you are discussing a hyperscale data center facility that consumes 500 megawatts of power, a 15% efficiency gain translates to millions of dollars in operational savings annually.
Not to mention a massive reduction in the cooling infrastructure required to keep the facility from melting down.
But wait, there's more to this, right? The transient response. I know this is perhaps the most critical engineering metric for an AI workload.
It is, the transient response being the system's ability to react to a sudden massive spike in power demand.
Give me an analogy for that, because transient response is heavy jargon.
Okay, think of traditional power delivery, like relying on the municipal water main when your house catches fire. You open the hydrant, but it takes time for the pressure to build, travel through the pipes, and reach the hose. By the time the water hits maximum velocity, the damage is done.
Ah, I see. So in a processor, if a massive computation starts and the voltage regulator cannot deliver the current instantly, what happens?
The voltage droops. The chip literally starves for power and crashes.
So traditionally, how do engineers fix that?
They have to overcompensate. They have to run the baseline voltage higher than necessary just to create a safety buffer against the droop, which burns even more wasted energy and generates more heat.
Okay, so how does Empower's IVR fix the transient response?
Empower's IVR technology is the equivalent of installing a highly pressurized water tower directly on your roof.
Oh, I love that analogy.
Because the silicon capacitors are physically integrated millimeters away from the processor core, the transient response is near instantaneous. The moment the AI workload sparks, the power is deployed natively without any lag.
That's brilliant. It eliminates the voltage droop completely, allowing the customer to run the processor at a lower, tighter baseline voltage, unlocking maximum performance safely.
Exactly. So returning to William Stein's question, ADI bought Empower because the physics of silicon trench capacitors and integrated regulation represent a completely different architectural discipline than legacy power management.
They just couldn't afford to spend 3 years researching and prototyping an internal IVR solution while the AI hardware market solidified its supply chains without them.
Time is of the essence. They bought the proprietary intellectual property so they can bolt it onto their massive global manufacturing and distribution engine to capture that hypergrowth accelerator market right now.
So when does this actually hit the bottom line? Analyst Chris Casso from Bader Bank asked when this acquisition would hit the income statement.
And Roche was remarkably measured about it. He clarified that the immediate revenue impact upon closing is negligible, but the strategic integration begins immediately.
Meaning they anticipate a massive surge in demand and significant material revenue scaling up in 2027 as the Empower tech is designed into the next generation of AI server architectures.
Right. It is a calculated play for indispensable criticality.
Okay, before we move off the sector breakdown, we absolutely need to address automotive. This segment represents 24% of ADI's revenue.
Yeah, and the top line metric looks somewhat anemic compared to industrial or data center.
Right, it's up 8% sequentially, but only up 2% year over year. However, if you listen closely to the underlying dynamics, there is a massive inflection point occurring.
There really is. The broader automotive sector, specifically the electric vehicle market, has been trapped in a painful inventory digestion cycle for the past 2 years.
Supply chain chaos led to overordering, followed by fluctuating consumer demand, leaving these massive stockpiles of unused components.
But Puccio highlighted a critical turning point on this call. ADI's battery management systems, the BMS solutions that monitor and protect individual battery cells in an EV, returned to year-over-year growth for the first time in 2 years.
Meaning the inventory glut is finally clearing out.
Exactly. Puccio noted they hit record performance in Europe and Japan, which managed to offset some ongoing sequential softness in the Chinese automotive market.
But the growth thesis in automotive isn't just about the total number of cars rolling off assembly lines, is it?
No, it's about semiconductor content density per vehicle. This is a vital distinction. Even if global auto sales stay perfectly flat at 80 million units a year, ADI's automotive revenue will continue to climb because the architecture of the car is fundamentally changing.
Right, because they're seeing explosive demand for their GMSL technology.
Yes, GMSL.
That stands for Gigabit Multimedia Serial Link. And this solves a massive physical problem in modern car design. Because as vehicles move toward higher levels of autonomy, you are adding high-resolution cameras, LiDAR arrays, and radar sensors all over the chassis.
And all of that raw, uncompressed data has to travel back to the central processing unit instantaneously.
But you cannot use standard Ethernet cables for that kind of bandwidth in a vehicle. Ethernet cables require multiple twisted pairs of wire. They are heavy, bulky, and highly susceptible to electromagnetic interference from the electric motors.
Right. If a radar sensor detects a pedestrian, you cannot afford a millimeter of latency or a dropped packet of data.
So what does GMSL do? It allows automakers to transmit gigabits of high-bandwidth video, audio, control data, and physical power over a single, lightweight coaxial cable.
Which is a game changer. It slashes the weight of the car's wiring harness, reduces the physical space required, and guarantees zero latency transmission.
Puccio specifically cited increased demand for GMSL alongside functionally safe power systems for next-generation advanced driver assistance systems, or ADS.
He even projected that we will see Level 3 ADS deployed in some vehicles within the China market by the end of the year.
Level 3 means the car handles all aspects of driving in certain conditions, allowing the driver to completely take their eyes off the road. The sheer density of analog sensors, GMSL links, and power management chips required to make a Level 3 system functionally safe and fail-secure is astronomical.
It really is. So we have established the operational baseline here. The headline numbers are record-breaking, and the structural tailwinds across industrial automation, AI data centers, and automotive electrification are incredibly robust.
But as we know, a retail investor cannot buy past performance. The market prices a stock based on future cash flows.
Right.
That brings us to management guidance. What exactly is ADI projecting for the third quarter, and more importantly, how resilient is that projection?
Forward guidance is the crucible of an earnings call. It is where management translates their market theories into hard, actionable projections based on their current order books. And for Q3, ADI is painting a picture of accelerating momentum.
They are guiding for Q3 revenue to hit $3.9 billion, plus or minus $100 million.
That is a massive sequential jump from the $3.62 billion they just delivered.
Huge. They expect EPS to climb to $3.30, plus or minus 15 cents, and they are projecting the operating margin to hold formidable at roughly 50%.
Puccio provided the sector breakdown for that $3.9 billion projection too. They anticipate above seasonal growth across their three core pillars. Industrial and automotive are expected to grow in the mid to high single digits sequentially.
And communications driven by that relentless data center demand is projected to be the fastest grower, expanding in the low to mid-teens sequentially.
Consumer is the only segment expected to contract, dropping single digits sequentially. But again, at 11% of the business, it's a minor drag on the overall engine.
However, this is where I have to step in and push back aggressively on the narrative.
Okay, let's hear it.
When a hardware company projects a massive near-term revenue spike of almost $300 million sequentially, while the broader macroeconomic environment is still highly volatile, my immediate suspicion turns toward channel stuffing.
Ah, channel stuffing. Yeah, explain the mechanics of channel stuffing for the listener so we understand the exact risk profile here.
Okay, so semiconductor manufacturers rarely sell single chips directly to the end user.
Right.
They rely on massive global distributors, companies like Arrow or Avnet.
Right.
If a manufacturer is desperate to hit an aggressive quarterly projection just to satisfy Wall Street, they can artificially inflate their revenue by offering aggressive discounts or favorable payment terms to force massive quantities of inventory onto those distributors.
So the manufacturer books the revenue today, making their guidance look brilliant.
Exactly. But it is a toxic illusion. The end market demand hasn't actually increased. You just moved the bottleneck.
Yeah.
Eventually, the distributors are choking on warehouses full of unsold chips. They freeze all new orders, and the manufacturer's revenue completely collapses 2 quarters later.
The classic trap.
So if ADI is projecting $3.9 billion, how do we know they aren't just stuffing the channel?
It is the single most critical risk to evaluate in hardware earnings for sure. But the data disclosed on this call provides a highly transparent defense against that exact fear.
How so?
Puccio explicitly detailed their channel inventory metrics. He stated that their channel inventory weeks, meaning the mathematical calculation of how long it would take distributors to sell through the current stock based on current demand, actually declined slightly.
Oh, wow.
Yeah, and it remains flat within their long-term target range of 6 to 7 weeks.
The 6 to 7 week supply is highly disciplined. If they were channel stuffing, that metric would spike to 10 or 12 weeks.
Exactly. The distributors are operating with lean, highly efficient stock levels. Puccio went deeper during the Q&A when analyst Tom O'Malley probed the automotive growth.
Right. O'Malley asked if the sequential auto bounce was just Tier 1 automotive suppliers restocking their warehouses after burning through their COVID-era stockpiles.
And Puccio rejected that thesis entirely. He stated that automotive customers are running incredibly lean on inventory. They're only ordering what they need for near-term production.
Meaning the forecast is anchored in real physical consumption.
Yes. The chips are being ordered because they are actively being integrated into EV battery packs and AI server racks today, not sitting on a distributor shelf waiting for a buyer.
Okay, I understand the distributor inventory is clean, but there is a potentially contradictory data point in Puccio's own remarks.
Which is?
He mentioned that ADI's own internal inventory increased by $81 million sequentially. And their days of inventory outstanding, their DIO, finished at 168 days.
Right.
That is almost half a year of internal inventory. Why are the distributors running lean at 6 weeks while ADI is hoarding massive amounts of stock internally? Is that just poor capital management?
It sounds alarming until you understand the physical architecture of semiconductor fabrication. Puccio defined this buildup as a strategic die bank and finished goods buffer. Let's translate the economics of a die bank.
Okay, so a die being the raw, unpackaged square of silicon that actually contains the integrated circuit.
Exactly. The manufacturing cycle of a complex semiconductor is incredibly long. Baking a silicon wafer through hundreds of lithography and chemical etching steps can take 90 to 120 days.
That's a huge lead time.
It is. But once that wafer is finished, the process of slicing it into individual dies and sealing it into the black plastic package with the metal pins only takes a few weeks.
But ADI packages the chip completely. It is permanently locked into a specific product configuration, right?
Right. If you package it as a radar sensor, it can never be an EV battery monitor.
Oh, I see.
But if you pause the manufacturing process right after the wafer is baked, and you stockpile the raw silicon die in a temperature-controlled vault, a die bank, you possess ultimate supply chain fluidity.
Oh, that's incredibly smart. You hold the core intellectual property, but you haven't committed the final packaging cost.
Exactly. If an automotive customer suddenly demands an emergency allocation of chips, ADI can pull the die from the bank, package it, and ship it in 3 weeks, completely bypassing the 120-day fabrication delay.
That is a brilliant capital allocation strategy. They are basically absorbing the inventory carrying cost internally to guarantee they never miss a massive high-margin order due to supply constraints.
They act as the ultimate shock absorber for volatile industrial demand.
And that leads directly to the final critical operational question of the call posed by Torres Vanberg. He recognized the massive surge in digital AI processor manufacturing. Foundries like TSMC are packed to the brim printing NVIDIA GPUs.
Right. So Svanberg asked, does ADI possess the physical manufacturing footprint to actually hit these massive growth projections, or are they going to get choked out of the foundries by larger players?
This is a CapEx risk. You can project $3.9 billion in demand all day, but if you physically cannot secure the foundry time to print the silicon, the revenue vanishes. How does ADI defend against external supply chain monopolization?
Vincent Roche and Rich Puccio outlined a massive structural overhaul they have executed over the past cycle. They have poured billions into capital expenditure to build total supply chain optionality.
Roche stated that since the pre-COVID cycle, they've more than doubled their internal manufacturing capacity.
Yes.
But I need to push back on that, because doubling your internal footprint carries massive risk. Fabs are fixed-cost behemoths. If you double capacity and demand slips, you are suddenly absorbing massive depreciation costs on idle factories, and your 73% gross margin collapses overnight.
That is the historical boom and bust trap of the semiconductor industry, for sure. But ADI mitigates this through that hybrid model we discussed earlier.
Right.
They doubled capacity for their mature, highly depreciated nodes where the capital investment is vastly lower and the product lifecycle stretch for decades. The defense contractor ordering radar chips in 2026 will still be ordering them in 2036. The baseline demand is locked.
And for the highly cyclical complex nodes, they rely on external foundries.
Exactly, but Roche noted they have completely restructured their foundry agreements. They have built strict geographical optionality.
Meaning they aren't reliant on a single factory in Taiwan to print their high-end chips.
Right. They have secured committed supply sources across different regions and geopolitical zones. Puccio stated with absolute conviction that between their expanded internal capacity and their highly diversified external foundry agreements, they possess the physical capability to support up to their long-term vision of $20 billion in annual revenue without hitting a supply chain chokehold.
$20 billion in capacity.
Yeah.
That indicates that management views this $3.9 billion quarter not as a peak, but as an intermediate step on a much longer growth curve. They have structured the physical and financial architecture of the company to absorb a massive multi-year scale-up.
Which perfectly aligns the data for our final evaluation. We have moved through the underlying mechanics.
Yes, we understand the sheer velocity of the headline numbers, the secular mega trends driving the volume, the physics of their strategic M&A, and the highly resilient operational structure supporting their forward guidance.
So it is time to distill this down to the actionable intelligence for you, the retail investor.
Exactly. To determine the ultimate structural health of analog devices, we have to look at the defensive moats surrounding their business model. And two specific data points from this transcript define that moat completely: their pricing power and their switching costs.
Let's examine the pricing power first. We already established that the current revenue surge was volume-driven, not merely an inflation pass-through. But the baseline pricing structure of ADI's portfolio is staggering.
Vincent Roche made a declarative statement during the Q&A that should really be the focal point of any investment thesis here. He said, "We've got the highest ASP by far in the industry, across the entire portfolio. We're at 4 or 5 times the industry average."
ASP meaning average selling price.
Right, so if generic commodity semiconductor costs the dollar, ADI is charging $4 to $5 for their component. And they are doing this while capturing market share and driving 37% year-over-year revenue growth.
Because they are not selling commodities. They are selling mission-critical solutions to severe physical engineering constraints.
An aerospace engineer designing a satellite communications array isn't sorting parts by the lowest price. They're sorting by absolute precision, thermal resilience, and guaranteed failure rates approaching zero.
ADI commands a massive premium because the consequence of failure for their components is catastrophic for the customer.
And that leads directly to the switching costs, or what Roche continually referred to as the stickiness of their products. This concept is the ultimate bedrock of ADI's financial stability.
Roche explained that the battleground for ADI occurs during the initial architectural phase, what they call the design-in.
Right. When a medical device manufacturer is first blueprinting a robotic surgical system, or an automaker is designing the chassis wiring for a new EV.
Exactly. ADI deploys massive engineering resources to ensure their specific analog to digital converter, or GMSL transceiver, is written into the foundational blueprint.
It is fiercely competitive at that stage. But once the ink dries on that blueprint, the dynamic completely flips.
Roche stated that once an ADI chip is engineered into the architecture of a complex industrial or automotive system, competitive substitution is effectively zero.
Let's dwell on that reality for a second. Competitive substitution is effectively zero. In a normal market, if a supplier raises prices, a competitor steps in with a cheaper alternative and steals the contract. Why doesn't that happen to ADI? If they charge 5 times the industry average, why doesn't an automaker just swap in a cheaper chip from a competitor halfway through the vehicle's production run to save money?
Because the friction of switching destroys the savings instantly. The analog chip is not an isolated component. It is deeply integrated into the system's logic.
Meaning what exactly?
If an automaker swaps the battery management sensor, they cannot just plug the new chip into the old circuit board. They have to redesign the physical board layout to match the new chip's pin configuration. Then they have to completely rewrite the thousands of lines of software code that interpret the analog data.
And crucially, they have to recertify the entire system.
Exactly. If you change a component in a functionally safe ADAS system or an aerospace radar, you have to run it through years of grueling regulatory and safety certifications all over again, costing millions of dollars in engineering hours and delaying the product rollout.
It makes absolutely zero economic sense to swap out an ADI component to save $3 on a $60,000 electric vehicle.
The switching costs act as an impenetrable financial moat. So when ADI wins a design in an industrial or defense platform with a 15 to 20-year life cycle, they are locking in 2 decades of highly profitable, guaranteed annuity revenue.
That extreme stickiness is exactly how you defend a 73% gross margin against cyclical economic downturns. So we arrive at the core question. What does this all mean? What does this deep dive reveal for the retail investor actively analyzing their portfolio right now? The macroeconomic environment remains clouded. Inflation is sticky, the consumer is under pressure, and geopolitical tensions are escalating. Is a hardware semiconductor stock structurally safe.
Based on the deep-level mechanics we have unpacked today, the readout from this earnings call is an aggressively bullish signal for the underlying enterprise. ADI is not a fragile, single-trend momentum play. They are a deeply diversified industrial powerhouse.
Diversification provides the ultimate structural hedge.
It does. If the retail consumer falters and stops buying high-end audio equipment, the consumer segment only represents 11% of ADI's revenue.
And if the electric vehicle market enters a protracted stall, ADI is perfectly positioned to absorb the shock with explosive 90% growth in their AI data center, optical, and power portfolios.
And if the broader commercial economy enters a recession, ADI is buoyed by multi-year locked-in aerospace and defense contracts fueled by sovereign national budgets that operate entirely outside of standard economic cycles.
They have engineered a portfolio architecture that forcefully captures the upside of global megatrends: artificial intelligence, automated digital factories, grid electrification, while completely insulating themselves from localized sector volatility through extreme technological stickiness and unprecedented pricing power.
They are the toll collectors on the bridge between physical reality and digital computation. For an investor looking for stability anchored by massive secular growth potential, the underlying machinery of ADI is operating flawlessly. So it's a fundamental hold.
Let's synthesize the crucial data points to lock down the narrative of this analysis. First, the financial velocity. ADI shattered expectations with $3.62 billion in top-line revenue, driven by organic volume and highly optimized product mix, resulting in an industry-defying 73% gross margin.
Second, the structural demand. Their industrial sector is surging at 56% year over year, anchored by defense modernization and digital factory automation. Simultaneously, the architectural shift toward AI has driven their data center communications business up over 90%.
Third, the strategic capital deployment. The planned acquisition of Empire Semiconductor. They are aggressively buying proprietary integrated voltage regulator technology, bypassing years of internal R&D to instantly capture market dominance in the power-starved AI accelerator ecosystem.
And fourth, the operational resilience. Management confidently raised forward Q3 guidance to $3.9 billion, supported by highly disciplined distributor inventory metrics and a restructured, globally diversified manufacturing footprint capable of scaling to $20 billion in annual capacity.
It is a remarkable blueprint of corporate execution in a highly volatile era. But as always, we want to leave you with a final vector of analysis to explore on your own. A structural reality that extends beyond the immediate quarterly projections.
We established the physical reality of the AI and EV revolution. The digital brains, the central processing units, and logic chips are governed by Moore's law. They historically get faster, smaller, and cheaper to produce over time as lithography improves.
But ADI's analog sensors, the nervous system, do not scale the same way. The physics of capturing a sound wave or a voltage spike requires specific physical geometries and specialized, highly engineered materials.
And we know ADI operates with an average selling price 4 to 5 times the industry norm, protected by switching costs that make their components effectively impossible to replace once designed into a system.
So as you model the future economics of global automation, ask yourself this: as the world demands exponential increases in real-time edge intelligence, and as the digital processing brain inevitably becomes a commoditized, cheaper component,
at what point does the compounding cost of these highly specialized, irreplaceable analog sensors become the ultimate financial bottleneck for the entire technological revolution?
if the brain is cheap, but the nervous system is incredibly expensive, the entity that controls the nervous system dictates the margins for the entire industry. It fundamentally shifts where the ultimate value accrues in the automated economy.
It is a fascinating structural dynamic to track over the next decade.
It truly is. We want to thank you for joining us on this deep dive. We hope we have helped you see past the binary, superficial signals of the stock ticker and understand the complex, powerful machinery operating underneath. Stay analytical, keep dissecting the data, and we will see you on the next deep dive.